Hello people, today we're going to talk about rotations. Now rotations, they're another type of transformation, and we say that they are, you can also call them like a turn. So a turn, we're going to rotate about what we call the center of rotation. So if you're rotating an image, say we have a little square and it's rotating around that image, that's the center. We call that the center of rotation. So you're rotating around. Now when you're rotating, there are some things we need to keep in mind. We're not really changing anything about the shape besides its position, and if it's getting rotated around, it's going to kind of change its orientation as it goes around. So that's one thing we need to keep in mind. Another thing that we need to keep in mind is if you do one full rotation, that's 360 degrees around, we're going to break it into three types. If you go 90 degrees, 180 degrees, and then 90 degrees in the other direction, and we'll talk about the directions and why they are important. And speaking of that, there's really two directions you can go when you're rotating. So when you're rotating something, you can go in this direction, and we call this specific direction, we call this clockwise. We call it clockwise because it's the way the hands on a clock move. They go around like this. If you're at the top, you're going to the right and coming down. So this is clockwise, this motion. We also have another direction that we'll talk about, and instead of being called clockwise, it's called counterclockwise. So it's going to go the opposite direction of this. So instead of going like the hands on the clock, it's going to go the other way. That's called going counterclockwise. And the direction will really help us with the rules that we cover today. So there's three main rules. I'm going to talk about them. If you want to make a little table of these, that might be really helpful for you. But the three rules we're going to talk about, and there's a rule for each one, is if we rotate clockwise 90 degrees, if we rotate just 180 degrees, the direction doesn't matter for this one. We're going to talk about why. And we'll talk about if we go counterclockwise. Counterclockwise. And that'll be 90 degrees as well. There are a couple things that I do want to mention before we get into the rules though. Going 90 degrees clockwise, if we have a coordinate plane here, let's say you're a square, and you go 90 degrees clockwise, that means you're going to end up right here. You go at 90 degrees, like you went 1/4, because 360 would be the whole way around. So you went like a quarter of the way this way. 90 degrees clockwise, it's actually the same thing. If you went the other direction, it would be like going 270 degrees in the other direction. Now the reason I'm mentioning this is because you might see this come up where instead of saying we rotate 90 degrees clockwise, it might say we rotated 270 degrees counterclockwise. So the directions are going to be really important, but these two are the same thing. Going clockwise 90 degrees is the same thing as going counterclockwise 270. So you can either go like 1/4 the way this way, or if you went in the opposite direction, it would be like going 3/4 the way all the way around in the opposite direction. So if you see 90 degrees clockwise, know it's the same thing as 270 degrees counterclockwise, and vice versa. So those have the same rule, and we're going to talk about that one. For 180 degrees, if you take any shape, we'll do a little triangle this time. If you have a triangle and you were to rotate 180 degrees, it doesn't matter which direction you go, because 180 degrees is exactly the halfway point, so it doesn't matter. The direction doesn't matter. Going counterclockwise or going clockwise 180, either way will get you to the same point. Direction doesn't matter. They're both going to be halfway around rotating. And counterclockwise, say you have your coordinate plane again, going counterclockwise 90 degrees, we'll say we have a square. Counterclockwise would be going the opposite of the clocks in the hand, so you'd be going this way. So counterclockwise would be going this way. And if you're going 90 degrees, this would be 90 degrees counterclockwise. That would be the same as going, if you went clockwise, following the hands of a clock, you'd be going 270 degrees if you went clockwise. So these two are the same. Going 90 degrees counterclockwise is the same as going 270 degrees clockwise. So we kind of have them grouped together. These two are the same thing, they'll have the same rule. 180 degrees doesn't matter. And these two are the same, they have the same rule in the end. So we're going to talk about the rule for each one of these, and we'll start with 90 degrees clockwise. So the rule for 90 degrees clockwise or 270 degrees counterclockwise, the rule for this is going to be, I'll do it in purple. If you start with a coordinate of x, y, if you rotate one of these two, which essentially will get you to the same point, you're going to end up at the coordinates of y, negative x. What this means is whatever your original coordinates are, you're going to flip them. They're going to change spots. So your y becomes your x becomes your y, and your x will change signs. I think with this, an example can be really useful. So let's say we start with 2, 7, and we want to rotate 90 degrees clockwise. That's going to end up being, well, your y, which is 7, that's going to become your x. So it's going to become 7, and your x is going to go where your y goes, 2, and it's going to become negative. So if we're rotating 90 degrees about the origin, like about the center, you're going to end up at 7, negative 2. And that's our rule for 90 degree clockwise. We'll do an example with that. We'll do it right here. So here's our figure, and we want to rotate this 90 degrees clockwise. It's always good to kind of map out in your head. Clockwise means you're going this way. So you're going with the hands of a clock, you're going 90 degrees, so it's like 1/4 the way. So you should end up somewhere around here. This also would be 270 degrees in the other direction. When you're doing rotations, it's good to list your points. So I'm going to write D. D is 2, 3. E is 1, 2, 3, 4. 1, 2, 3, 4. E is 4, 4. And F is 1, 2, 3, 4, 5, 1. If we're going about the transformation of a 90 degrees clockwise, that means we're going to end up, again, somewhere in this area. We should be expecting the triangle to go down here. Let's go in red. So what's going to happen with all of our primes here is, going back to our rule, your x is going to change signs and become your y will become your x. So 3 becomes x, and 2 changes size and becomes y. Your x was 4, so it's going to become a negative 4 for your y becomes your x, so you have 4, negative 4. Your y becomes your x, so it's 1, and then negative 5. So these, right here in red, those are going to be your final points, your final coordinates. If we go ahead and graph them, let's say we do D first, and this was point D right here. We have 1, 2, 3, negative 2. This becomes D prime. E is 1, 2, 3, 4, down 1, 2, 3, 4. Here's E prime. And F is 1, negative 1, 2, 3, 4, 5. So here's your F prime. I'll go ahead and draw the triangle. And if you notice, this is a congruent triangle. And it's gone 90 degrees in this direction. Your center of origin, or your center of rotation, is your origin here. It's kind of like you're on a racetrack and you're just doing like a lap around. You're just driving in a circle around. So since F was in the beginning of, you'll say this triangle car driving here, it's going to end in the beginning here. Like it's just going around in a rotation with this being the center. So these are your final points, and this is what it looks like. You've gone 90 degrees clockwise, or you could say 270 counterclockwise. You might see it written either way. All right, on to our next rule. Our next rule, we are going to do 180 degrees. So with 180 degrees, again, the direction doesn't matter for 180 degrees. And we're in red here. And here's the rule of how it works. You're going to end up staying where you are for each coordinate, but you're going to change signs. So if you're xy, you're going to become negative x, negative y. An example of this, if you had the point 6, negative 1, and you go through the rule, you're going to become -6, +1. Each coordinate stays where it is, but it changes signs. So the 6 becomes the opposite, and the -1 becomes the opposite. This would be your final coordinates. In our example for this one, we're going to have a triangle, and it looks like this. Here we go. And we're going to rotate this 180 degrees. Here's our triangle. Again, we want to go ahead and list our coordinates to start. L is -3, 2. Y is -1, 2, 3, 4, 4, -4, +4. And Z is -2, 1, 2, 3, 4, 5, -2, 5. The rule that we are transforming by is a rotation about the origin, and it is 180 degrees. So we're going to go ahead and we're going to end up with L prime, Y prime, and Z prime. And for 180 degrees, our rule, 180 degrees, X, Y, they stay where they are, but they change signs. So -3 stays where it is, but it changes signs. So it becomes 3, -2. -4 becomes +4, +4 becomes -4. And everything down here changes signs. So we're left with these coordinates. I'll go ahead and graph them. We have 3, -2. That's going to be L prime. We have 4, -4. That's going to be our Y prime. And we have Z is 2, -2, 4, 5. That's your Z prime. So here's your triangle. And this would be if you rotated 180 degrees either clockwise or counterclockwise. They're both going to end up at the same spot here, counterclockwise and clockwise. You've gone exactly halfway around that circle that's centered right here at the origin. That's your center of rotation. So your final coordinates, and this is the final image. Don't forget the prime symbols. All right, on to our last rule here. Our last rule is going to be counterclockwise 90 degrees or clockwise 270. They'll get you to the same spot. And this rule is, if you start with X, Y, and you rotate one of these two, you'll end up with -y, x. And an example of this, the trick with all of these is really just knowing how the rules work. If we had, separate them, if we had -4, 2, and we did one of these two rotations, your x is going to become your y is going to become your x, but it's going to change signs. So your y is 2, it's going to become the opposite though, and it's going to become your x, so it becomes -2. Your x, which is -4, is just going to become your y as -4. So that would be your new points here. And we're going to do one more example, one with this now. Let's say we have these 4 coordinates, and we want to rotate 90 degrees counterclockwise. So if you're rotating counterclockwise, notice that a clockwise is this way, so counterclockwise is the other way. 90 degrees is like 1/4, so you're going to go down, and you should be expecting everything to be around here. Or if you went 270 clockwise, you'd end up around here. So try to map out where you should expect everything to end up. Then we'll go ahead and list our coordinates. We're going to have P, C, R, and E. So P, we have -3, 2. C, we have -2, 1, 2, 3, 4, 5. -2, 5. R, we have 1, 2, 3, 4, -5. 1, 2, 3, 4, 5, 6. -5, 6. And E, we have, well, -6. And then 5 up. And we are going to be following the rule of counterclockwise 90 degrees or clockwise 270. So your y becomes your x, but it changes signs. Your x stays the same and becomes your y. So we're going to have P prime, C prime, R prime, and E prime. We can fit them all in. So again, your rule, your y is going to become your x but change sign, so it should become -2. and then your x stays the same, and is your y. So we have -3. Y becomes your x, but changes signs. Your x just becomes your y and stays the same. Y becomes your x and changes signs. X becomes your y. Y becomes your x and changes signs. X becomes your y. These are our points now. P prime is -2, -3, -2, -3. There's P prime. C prime is -5, -2. C prime. R prime is -6, -5, 2, 4, 6, 2, 4, 5. That's your R prime. And E prime is -5, -6, which is right here. Notice how this figure is congruent. It's the exact same shape, but it's just been rotated. Or it's been rotated down. And that would be a 90 degrees counterclockwise. 90 degrees counterclockwise turn here. There's your coordinates. This is your final image. So that's how we can do rotations, just another type of transformation that we can now complete on the coordinate plane. So go ahead and try a few of these on your own in that IXL, and have a nice day.